Arup is the creative force at the heart of many of the world's most prominent projects in the built environment. Our engineering, planning and advisory services professionals blend technical expertise with a drive to shape a better world. We are truly global, with more than 14,000 people in 88 offices across 33 countries. We have been delivering landmark projects since our foundation in London in April 1946. Our Dublin office opened 3 months later, with the company continuing to grow to become one of the largest consulting engineering practices in Ireland. With an enduring set of values, our unique trust ownership fosters a distinctive culture that encourages collaborative working. This allows us to develop meaningful ideas, help shape agendas, and deliver results that frequently surpass the expectation of our clients. Arup is committed to using expertise, creativity, and innovation to make this world a better place for all. Cherrywood is located in the south part of Dublin in Ireland. The new town centre development includes a combination of residential, retail, parks and office space. This developing suburb is an important residential and employment settlement to the south of Ireland's capital city. Cherrywood Grand Parade Bridge will form an integral part of the town centre. It will tie into the existing light rail viaduct and will accommodate 2 cycleways, a footpath and Grand Parade Road, which runs adjacent to existing light rail track. It is primarily important for the bridge to provide a connection within the town centre on either side of Wyattville Link Road and provide shelter from wind and rain for all pedestrians. Considering the complexity of the project and to optimize constructability and coordination with architects, our client Heinz and other external project stakeholders, we made the conscious decision to fully model the bridge in 3D. The scope of the new bridge works included a new bridge in form of widening of the existing rail viaduct and the provision of a new pier and abutments. The structure consists of 2 spans each of 22.5 meter length. The new bridge varies in plan with over 60 meters at the pier location. The superstructure consists of composite steel girders with an in-situ concrete deck and curved concrete parapets. Second, the architectural facade along the eastern side of the newly widened section with a superstructure of approximately 9 meter height and structurally connected to a torsion steel box that is composite with the deck along the curved edge of the bridge. Third, the architectural facade along the western side of approximately 5 meter height and structurally connected to a new torsion steel box which ties into the existing bridge and the abutments of the light rail viaduct. Fourth, piled foundations to all supports of the new bridge. Prior to the design commencement, we had to make a decision regarding the modeling workflow. It was obvious that for available resources and skills, the Bentley platform provided the most efficient solution. With a parametric link between ProStructures, OpenBridge and OpenRoads, it was possible to progress modeling and detailing prior to the final geometry being confirmed by the architect and the road designer. The geometry modeling did not require scripting or post-processing, facilitating the project being delivered by a much smaller team than would usually be required to design a bridge of this complexity. The model information was easy to use as reference geometry in the global and the local and the CFD analysis. Bentley software was chosen due to our desire to perform accurate 3D bridge modeling and detailing for the entire project, which was a unique decision in Ireland. The intelligent and interactive use of digital workflow involving OpenRoads, OpenBridge and ProStructures reduced risk and mitigated design errors. The data collaboration, communication and management processes using Bentley tools allowed the project to be delivered within budget and timeline. Carrying out the point cloud survey assured confidence in the model and mitigated potential changes that could occur during the construction process, thus saving materials and reducing the carbon footprint. Cloud points features included in Bentley software allowed the modeling of the new deck geometry tied to the existing structure. With a great accuracy, we were able to develop the steelwork geometry of the west facade box and brackets to tie with existing supports. With 3D models being data-rich, opportunities to use the models to provide additional information beyond the scope of this project were considered from the outset. as a way to provide added value to the client and contractor. Arup recognizes the potential benefits that can be derived from these models. This is a proactive and new initiative in our industry in Ireland. The new models that Arup delivered are ready for inclusion in the asset management process, forming the ultimate connected data environment. The bridge models were shared with the external quantity surveyor. Considering industry foundation classes for infrastructure have not yet been officially published, we use the iModel format to store information about the bridge geometry. The iModel hub was used to store models and enabled coordination between Arup, the architects, and external consultants. The iTwin design review allowed the team to track comments and responses raised during technical reviews. Project work streamlined by implementing a workflow built around ProjectWise. This solution improved the consistency, quality, and efficiency of the project team. The extraordinary support and cooperation with Bentley support team improved our efficiency of delivering the complex 3D geometries of the reinforcement and steelwork, and production of 2D drawings, while at the same time allowing us to contribute to enhance the software features. Delivery of traditional 2D drawings and schedules was the main element of our scope. Thus, it was crucial to develop a workflow that would provide an honest presentation of our 3D models. Modeling in 3D provided added benefits of sharing accurate scheduling information pulled directly from our models for the quantity surveyor. OpenBridge reduced the time required for modeling by at least 50% compared to alternative solutions. We were able to fast-track parametric bridge geometry modeling and offset the additional time to expand our skill set in ProStructures, as we had never used this software before. Setting up the production of drawings using sheet indexing automated and improved the plotting process for the different suitability stages and submission revisions. Bentley LumenRT had a vital role of providing added value to the project. We produced high-resolution images and videos, including 3D YouTube, and virtual reality models to receive feedback throughout the design process. Visualizing the design intent provided high value to the client and design team. Virtual reality sessions showing the rendered bridge model with the inclusion of coordinated design elements from other external consultants provided meaningful insights into the proposed design, beyond the scope of this project, at a very little effort. The Bentley system workflow streamlined the design process for Cherrywood Grand Parade Bridge, enhancing communication and productivity for the team. The intelligent parametric modeling and seamless link between OpenBridge, OpenRoads, and ProStructures enabled this project to be delivered according to a tight program. With ProjectWise in place and using iTwin Design Review, the project was shared and collaborated on by stakeholders in a controlled manner. Delivering the project with a comprehensive 3D modeling approach required a learning curve and numerous challenges linked with the implementation of the new technology. The data collaboration, communication, and management processes between Bentley tools allowed the project to be delivered within the agreed budget and timeline. The level of details achieved in the 3D models and drawings will be highly beneficial as the project progresses into the construction stage. We are proud that at the end of the project, we succeeded in modeling all parts of the bridge in 3D. We proved that people with ambition and passion can overcome challenges and make the impossible possible, delivering an honest, cutting-edge design. Thank you.